Hello, my shimmering stars. Today, I, Shaura Grover, welcome you all to this amazing platform of PW Gulf. Students, I welcome you all to your Triumph Ultimate Recap session. And today, we are going to start with the chapter Alcohol, Phenol, and Ether. I hope so, students, you have seen the previous session that was about haloalkanes and haloarenes, and you were now clear with, how to proceed towards organic chemistry. If I talk about class 12 standard, over here students in class 12, it's very simple that you have to start with methods of preparation. Then you need to proceed further with physical properties and then the chemical properties. So it is very basic if you'll move on to that part. Like you can divide a complete chapter into 3 parts and you can cover it up. Similarly, as we did in haloalkanes and haloarenes, we are going to do in that way in alcohol, phenol and ether, and in the same way, we'll be continuing to the next chapter of ours, that is aldehyde ketones and carboxylic acid. So students, let's get ready for this particular session of ours. Now what are we going to do, ma'am? How are we going to start with? So first of all, I will be letting you know that what exactly is alcohol, phenol and ether. Okay, first of all, we'll be understanding the general introduction part of them. So initially, we'll be doing introduction. After introduction, students, we shall be understanding about, first of all, we'll complete alcohol completely, phenol completely. Okay, we'll do the methods of preparation first of all, methods of preparation, and then of both of them, we are going to cover physical and chemical properties. Physical and the chemical properties. And at last, students, we shall be covering your ether part, right? So this is the way how we are going to cover our complete session today. So moving further, students, let us first of all, before understanding the methods of preparation, let us first of all understand the introduction part, that what exactly is alcohol or phenol or ether, right? So now we are going to start with the introduction of ours. Over here, you should know that what exactly is alcohol. Now, it's very simple that, for example, in any hydrocarbon, let's consider an alkane, if we are removing one hydrogen atom and we are adding one OH group, that is the hydroxy group, that basically refers to as what? Your alcohol, right? So, when one hydrogen atom is being replaced in aliphatic hydrocarbon, by OH group, that is referred to as your alcohol. Let's take a general example of it. For example, if I have CH3, let's consider this. Now, when I am removing one hydrogen from this and I am adding one OH group over here, that means it is this. So, this creates your alcohol, right? We can take further few more examples of alcohol, such as this. We can take further more and more examples. Such as this. So they all are categorized under alcohol. They all are categorized under the category alcohol. Here we need to understand the very basic part, that here we are using a word aliphatic hydrocarbon or an aliphatic chain. Aliphatic refers to as the straight chain, basically an open chain, basically. In general, straight chain, but yes, it is preferably used for open chain compounds. Okay. Now, when I'm talking about what exactly is phenol, ma'am, what exactly is phenol? So when I will say that when one hydrogen atom of aromatic hydrocarbon is replaced by OH group, that creates your phenol. So now What is the general basic difference over here? That here we are using a term aromatic hydrocarbon. There we used aliphatic, here we are using aromatic. Aliphatic is an open chain, aromatic is closed chain. Generally, we are taking an example of benzene directly over here. So, we say that for example, this is our benzene ring and I am removing one hydrogen and I am adding one OH. This creates your what? This creates your ma'am phenol. Clear with this part everyone? Okay. Now comes the third part of ours, that is what exactly is ether. Yes? What exactly is ether? Let's do that. The third part is ether. The third part is ether. Now when I am talking about the term ether, students over here, what is ether? Sorry. What is ether? When one hydrogen atom is replaced by either OR group or by O and then your aromatic ring group, it is basically an ether. How come, students? For example, see, in general, if you have RH, okay, this is what is an hydrocarbon, no? Now, you are replacing this hydrogen from this hydrocarbon. Let's take CH4 you have. So, you can write CH4 as CH3H. In the same way, I have written it as RH. RH is a general representation of any hydrocarbon. Now, what I am doing is I am removing this hydrogen over here and I am going to add what? Either I am going to add OR group or I am going to add this group over here. See, if I am going to add that, let's remove hydrogen and then add this part. You will get ROR. Or what are you going to get? Or you will get RO and then the aromatic ring. So they both are basically what? They both are ether. What is the general formula? What is the general formula of ether? So it is basically ROR. This is basically the general formula of ether. The general formula of ether. Now I guess you are very well aware of alcohol, phenol and ether. What are these three? Yes, everyone? Okay. Now, let's start with the classification of alcohol. Let's proceed with the next segment, that is classification. That is classification of alcohol. Understand, students, while I am classifying alcohol, I can classify them or based upon different categories. Okay. Let's say, first of all, I am going to categorize themselves. I am going to classify themselves based upon the number of OH groups attached. Okay. So, now the classification that I am going to do is, it is based upon number of OH group present. Number of OH group present over there. Now, see, students, if I am talking about this part, the very first is monohydric alcohol. Monohydric alcohol. What is a monohydric alcohol? When there is only one OH group present in a compound, that creates your monohydric alcohol. When only one OH group, when only one OH group is present in a compound, that is basically your which kind of an alcohol? That is monohydric. That is monohydric alcohol. Clear with this part? Let's take a general example. When there is only one OH group, so I can say CH3, CH2OH. I can say CH3, CH2, CH2, CH2OH. Even I can say CH3OH. Any example you can take. Let's take something of a branch chain. CH3, CH, CH3OH. All of these contains only one OH group. So, all of them are basically the monohydric alcohol. The monohydric alcohol. Yes, everyone? Now comes the next part, that is dihydric. That is dihydric alcohol. Now, what exactly it is, ma'am? What exactly it is, ma'am? When two OH groups are present in a compound, that creates your dihydric alcohol. When two OH groups, are present are present in a compound that is dihydric alcohol. Let's take few examples of this as well. CH2OH, CH2OH. So this is an example of dihydric alcohol. You can take further more examples. CH3, CHOH, CH2OH. You can take any example, whatsoever you want to. You can take example of dihydric alcohol. Even you can say it like this: CH2OH, CH2, CH2OH. Any example you can take over here. Right? Now, trihydric alcohol is the third category. What is the third category, ma'am? It is trihydric. It is trihydric alcohol. It is trihydric alcohol. What is a trihydric alcohol? When, ma'am, 3 OH groups are present. When a compound contains 3 OH groups. 3 OH groups, that is a trihydric alcohol. Let's take a general example. So this is a general example where we have 3 OH groups present over there. So this is what is monohydric alcohol, dihydric alcohol and the trihydric alcohol. Now this was based upon what, ma'am? This was based upon the number of OH groups present in a particular compound. Now we are going to start, that depends upon the degree of carbon. Classification based on based on degree of carbon atom to which OH is attached. Okay, now we are going to do that classification. So the very first over here, students, is going to be what? It is going to be 1 degree alcohol, or I would say primary alcohol. 1 degree alcohol or primary alcohol. It is that alcohol in which OH group is attached to a primary carbon. Okay. So 1 degree alcohol or a primary alcohol is that alcohol in which OH group is attached to 1 degree carbon, or I would say is attached to primary carbon. Let's take a general example. CH3, CH2OH. Now see, students, over here in this particular part, OH is attached to this carbon. What is the degree of this carbon? This carbon is further linked with only one carbon. So this carbon, ma'am, is 1 degree carbon. Hence this complete alcohol is your primary alcohol. Or what I can say is 1 degree alcohol. Clear with this part? Okay. Let's take one more example over here. CH3, CH2, CH2OH. For example, I have this particular thing over here. So now see, this OH group basically is attached to a carbon, which is which kind of a carbon? 1 degree carbon. Why? Because it is further linked with only one carbon. So this is also what? This is also a primary alcohol. This is also what? A primary alcohol, or I would say a 1 degree alcohol. Clear with this part, everyone? Okay, that was about primary alcohol, or I would say 1 degree alcohol. Now let's do about secondary alcohol or 2 degree alcohol. What is a secondary alcohol or a 2 degree alcohol? Let's understand this now. What is a secondary alcohol or a 2 degree alcohol? Alcohol in which OH group is linked to, is linked, or I would say, or attached to, or linked or attached to 2-degree carbon. Okay, where OH is attached to a 2-degree carbon. Let's take few examples over here as well. If I'll say CH3, CH, OH, CH3. Now students, what are you observing over here, ma'am? That this OH is attached to this carbon. What is the degree of this carbon? This carbon degree is, ma'am, 2 degree. Why is it 2 degree? Because it is further linked with 2 carbons. So if it is attached to a 2-degree carbon, this kind of an alcohol is which kind of an alcohol, ma'am? A secondary alcohol, or I would say a 2-degree alcohol. Simple, easy part, right? Now comes 3-degree alcohol or the tertiary alcohol. The third category is 3-degree alcohol, or I would say tertiary alcohol. Now what is a 3-degree alcohol, or I would say a tertiary alcohol, everyone? When OH group is directly linked with a 3-degree carbon. When OH group is attached to 3-degree carbon, that creates your 3-degree alcohol. Let's take an example. Now see students, in this particular case, OH is linked to this carbon. And what is the degree of this carbon? This is linked with 1, 2 and 3 carbons. So the degree of this carbon, ma'am, is 3-degree carbon. Hence this compound over here is tertiary alcohol. Is what is tertiary alcohol, everyone. Is it clear to each and every one of you? Now this classification was based upon the degree of carbon. That means OH group is attached to which kind of a degree of carbon that creates the degree of, that creates basically the degree of alcohol. That is the classification of alcohol. Next comes the classification that is based upon hybridization. Next comes classification based upon what? Now about hybridization. Okay, let's see this one. Now in this particular part, the very first that we are going to start with is allylic alcohol. The first that we are going to start with is allylic alcohol, everyone. What is the allylic alcohol, everyone? Allylic alcohol is that alcohol in which OH group is linked to a carbon which is further linked with a doubly bonded carbon. For example, first of all, let's write it. When OH group is attached to allylic carbon, or if you want to define it, or a carbon which is linked, which is sp3 hybridized, and is further linked with a double bond carbon atom. Let's see the example of the allylic alcohol, students. Example is very easy. This is our OH group. This is linked to a carbon which is further linked to a doubly bonded carbon. Getting my point? Everyone? Let me write it again. So your example is, this is your example, students. Now just observe it over here. Just observe it. This OH is linked to a carbon which is sp3 hybridized, very simple. And this is linked further to a doubly bonded carbon atom. So this is what is an allylic alcohol. Clear with this part? That's really great. Now students, comes the next category, that is vinylic alcohol. That is vinylic alcohol. Now ma'am, what is a vinylic alcohol? It is basically that kind of an alcohol in which OH group is attached to a carbon that is sp2 hybridized and is creating a double bond with another carbon. Okay, so when OH group is linked with carbon which is sp2 hybridized and itself is creating a double bond, and itself is creating a double bond. That is what is your vinylic alcohol. What example you can take over here in the case of vinylic alcohol? This is your OH. It is attached to a carbon which is itself creating a double bond. And when we are going to fulfill the valency of carbon atoms with hydrogen, just observe the hybridization of this carbon is sp2, to which OH group is attached. So this creates your vinylic alcohol. Clear with this part? That's really great, students. Now comes the third category, that is benzylic alcohol. Benzylic alcohol. Now students, as the name itself says benzylic, so many a time students just think that benzylic, that means OH group attached to benzene ring. But this is completely wrong. When OH group is attached to a benzene ring, that is creating your phenol, not your benzylic alcohol. Remember that benzylic alcohol is that alcohol in which OH group is attached to a carbon which is further attached to a benzene ring. Okay, so you can say when OH group is attached to a carbon, which is further attached to benzene ring, That means if I am taking an example, this is your benzene ring. So this is carbon and this is OH. So over here, this is your benzylic alcohol. OH is attached to a carbon which is further linked with a benzene ring carbon atom. Clear with this part? This is benzylic alcohol. So this ends our classification with regard to alcohol, students. Now in phenol there is no as such classification, but yes, in ether there is a classification. So now we are going to do classification of ether. Now I already told you what exactly is ether. Ma'am, ether is ROR. Now when we are going to do the classification of ether, it can be categorized into two major types. The very first, students, is symmetrical ether. And the second one that I am talking about over here is unsymmetrical ether. Now what is a symmetrical ether and what is an unsymmetrical ether? Along the O group, for example, you have RR group along the O, right, oxygen atom. So, sorry. When there is same groups on both the ends, that is a symmetrical ether. When there are the different groups, that is an unsymmetrical ether. Right, everyone? So, basically, ROR is a symmetrical case. And what is an unsymmetrical case, ma'am? It is ROR dash. This is an unsymmetrical case. Very simple, very easy, very clear. Okay. Now, let's take a general example of symmetrical ether, that is CH3OCH3. That is C2H5O C2H5. That means over here both the groups are going to be same. But over here in the unsymmetrical ether, it is CH3OC2H5. Or you can say CH3CH2O CH2CH3. When there is different number of carbon chains on both the ends, that creates an unsymmetrical ether. So this is basically the classification of ether, students. Now we are going to come to the part of nomenclature. Let's talk about the nomenclature. Of alcohol, phenol and ether. Now let me tell you, the nomenclature rule is very simple, though when I have explained in the class 11 standard about IUPAC nomenclature. If students, you don't know how to name an organic compound, in the on PW Gulf YouTube channel itself, we have created a video based upon the IUPAC nomenclature part. Go over there, watch that video, you will be able to solve nomenclature very easily. But if you have done so, you can quickly revise over here. What is the general formula in order to do the nomenclature? So general formula includes that at At the centermost position, you need to write what? At the centermost position, you need to write word root. Word root represents the number of carbon atoms that are present in a parent chain. At the right hand side of the word root comes primary suffix or 1 degree suffix, which represents the bond between the carbon and the carbon atoms. If it is a single bond, you have to use primary suffix as ane, A-N-E. If it is a double bond, you have to use ene, E-N-E. And if it is a triple bond between the carbon and carbon atoms, you have to use Y-N-E, ine. Now this was about primary suffix. At the right hand side position of primary suffix comes secondary suffix. Secondary suffix is used for functional groups. Now here, when I am talking about alcohol, for alcohol, secondary suffix will be used as ol, O-L, ol. Remember, if you use A-L, that creates an aldehyde. O-L will refer to as for alcohol. Clear? Now, just at the left hand side position of word root, we have primary prefix. Primary prefix, students, represent basically, it is generally used for an open chain and a closed chain compound. For closed chain compound, we are going to use cyclo. But for an open chain, we are not going to use any word for the primary prefix. And secondary prefix is used at the left hand side position of primary prefix. This is basically generally used for many of the things. The very first is for for junior most functional group. This is used for senior most, that is used for junior most functional group. The second category that you can use for secondary prefix is for extra group, for side chain and all of that stuff. Okay. So secondary prefix, if I am talking about for the case of alcohol, students, you have, if you are using it as a secondary prefix, you will be using hydroxy. You will be using what word? Hydroxy word. Do remember that. Now I am taking some few examples over here so that we can understand how IUPAC works. So if I am giving you CH3, CH2OH, what is going to be its name? Ma'am, it's very simple. It's 1 and 2 carbon atoms in the parent chain. So for 2, we have eth as a word root. Now primary suffix for carbon-carbon single bond, it's very simple. It's ane, ma'am. A-N-E, ane. And now we have OH group. For OH, we have to use ol as a secondary suffix. It is present on the first carbon atoms. See, I'm going to eliminate ethane E. Why? Because two vowels cannot come together. So it's ethane 1 ol, or you can even say ethanol. Remember, we need to mention the number at which the functional group is attached. But in general, if they are directly writing ethanol, it is directly telling you that it is present on first carbon atom. When they are not mentioning you the number, that means they are telling you that the functional group basically is attached to the first carbon atom. Clear with this part, everyone? So this is your very first case. Let's see the next one. Let's take one more example. For example, students, if you have this case. Now, in this particular case, again, it's 1, 2, 3 and 4. For 4 carbon atoms, what is going to be the word root? Ma'am, it is going to be bute. For carbon-carbon single bond, primary suffix is going to be ane, A-N-E. For secondary suffix, we have carboxylic acid, that means oic acid. If carboxylic acid, COH, is included in the parent chain, we are going to write oic acid. If it is not included in the parent chain, we will be writing directly carboxylic acid. Now, it is included in the parent chain, so oic acid will be used. It is present on the first carbon atom, so it is butane 1 oic acid. I have deleted butane E. Why? Because oic acid starts with O, that's why. Now, we have OH, but it is not present in the parent chain. That means it is not included as a secondary suffix. Why? Because it is not senior most functional group. Carboxylic acid will be the one. So it will be acting as a junior most functional group, and for the OH we are going to use hydroxy. So it is going to be 3 hydroxy butane 1 oic acid. I guess now you can clearly do that easily. Yes, everyone. Now let me tell you the nomenclature for ether. The nomenclature for ether. Remember, if we'll be doing for anything that contains a benzene ring, for that we have to directly use what? Instead of word root and primary suffix, we'll be using directly benzene. Okay. Coming to for the nomenclature of ether, we have symmetrical ether. We have symmetrical ether, and the second one is we have unsymmetrical ether. We have unsymmetrical ether. When I'll be writing about symmetrical ether, that means it is general formula is ROR, and if I'll be talking about unsymmetrical ether, that is general formula is ROR dash. Clear? Now, what is the common name that we can use for symmetrical ether? It is dialkyl ether. It is dialkyl ether. This is the common name that is used for whom? Symmetrical ether. For unsymmetrical ether, what is the common name? It is alkyl ether. Alkyl ether. And over here, the initial alkyl, how you are going to write it? Because it is unsymmetrical. So here, alkyl and alkyl you have to write based upon the alphabetical order. You have to write this based upon the rule of alphabetical order. Clear with this part? This is about the common name. Let's write the IUPAC name. Sorry. IUPAC name in the case of symmetrical ether is going to be alkoxy alkane. It is going to be what? Alkoxy alkane. Here also the IUPAC name is going to be same. It is going to be alkoxy alkane. Just remember one part over here, that over here in this particular case, this alk is used for carbon which is less, and this alkane alk is used for the carbon more. Okay, now this was about the common name as well as the IUPAC name. This was about what? This was about the common name as well as the IUPAC name. Now let's take some few examples of it to understand it more clearly. Now first of all students, I am being talking about the symmetrical ether over here. Now in the case of symmetrical ether, let's take a general example of CH3OCH3. What is going to be the common name in this particular case, ma'am? It is dialkyl ether. What it is? Dialkyl ether. So it is di and it is methyl, no? So it is dimethyl ether. Dimethyl ether. Now what is the IUPAC name over here, ma'am? What is the IUPAC name that we are going to use? Alkoxy alkane. So it is going to be what, ma'am? It is going to be methoxymethane. Yes. Now let's take a case for the unsymmetrical ether also. Let's take a case for unsymmetrical ether. Let's take CH3OC2H5. Okay, now what is going to be the common name in this particular case, ma'am? The common name is alkyl ether, and it depends upon the alphabetical order. So it is methyl, it is ethyl. For one carbon is methyl, for two carbon it's ethyl. So as per the ABCD order, ma'am, E comes first. So it is going to be ethyl. It is going to be methyl ether. It is going to be what, ma'am? Methyl ether. Now what is going to be the IUPAC part over here? What is going to be the IUPAC nomenclature over here? Ma'am, it is alkoxy alkane, and alk, initial alk stands for carbon less. In this we have less carbon, so it is methoxyethane. The second one will be using for more, so it is ethane. So it is methoxyethane. Everyone just write it down. Now I'll be moving on to the methods of preparation part, but before that I would request everyone to write it. Done with this part. Okay, that was about nomenclature. Now students, we are going to start with methods of preparation of alcohol. In general, how alcohol is being prepared, right? So there are many reactions, students, in order to prepare alcohol. So let's start with the very first method of preparation that I am proceeding over here. That if you are taking CH2 and CH2, let's take alkene, CH2 double bond CH2. Now when you are talking about alkenes and you are preparing, your alcohol with the help of alkenes, there are various methods. Hydroboration, oxidation, oxymercuration, demercuration, and then we have, our acid catalyzed hydrogenation. So all of these reactions basically are the methods of preparation for the alcohol. Now as you very well know, students, this is basically an ultimate recap session. Now what is the word ultimate recap? That means complete revision in one particular session. Now when I'm talking about revision, I shall be always talking about the flow charts. In haloalkane, haloarene also some of the topics we have done in the same way. Now in all the chapters of organic, as you know, this is a revision part. I guess you all have studied the chapter in detail. So we'll be creating flow charts, and with the help of that we are going to learn it out. So if you're taking alkenes and if you're going with acid catalyzed reaction, that means in the presence of water you are doing this reaction. Now water contains H positive and OH negative. Remember, if you are taking this case of CH2 double bond CH2 and you are taking acid catalyzed reaction where you are taking water, that means H positive and OH negative. So what you have to do in that particular part? Okay, sorry. So what you have to do in that particular part, there, extremely sorry. There which rule will be followed? There Markovnikov rule will be followed. What is Markovnikov rule? Markovnikov rule says that negative part will go to that double bond carbon atom, which has less number of hydrogen atom, which has less number of hydrogen atom. So that's why if I am taking this, yeah, I guess now it's okay. Yeah. So that's why when I'm talking about, the Markovnikov rule, negative part will move on to that doubly bonded carbon atom which has less number of hydrogen atom. Hence, what will happen in this particular case? In all of these cases, you are just adding water. You are just adding water. And when you are adding water, you are adding H positive and OH negative. Just understand this key concept. If you are taking an acid catalyzed reaction, over here, if you are taking CH2 double bond CH2, you are adding H positive OH negative. Under Markovnikov rule, in the symmetrical case, just break the bond, provide one hydrogen and one OH2, one carbon atom. So you'll get an alcohol. Let's take the case of an unsymmetrical one. So if you are taking an unsymmetrical alkene over here, again you are adding water. You have to follow which rule, ma'am? The Markovnikov rule you have to follow. Negative part will go to that doubly bonded carbon atom which has less number of hydrogen atom, and H positive will go over there. Double bond will break. What are you going to get? You will get CH3, CHOH, CH3. Clear with this part, everyone? It was a very easy, a very simple reaction. Now we are going to start with hydroboration oxidation. Let me tell you about hydroboration oxidation. This is an example of hydroboration oxidation. This is basically which one? This is basically hydroboration oxidation. Hydroboration oxidation. And in hydroboration oxidation, what you have to do, you have to indirectly add water. With the help of which rule, ma'am? Now in this, with the help of which rule, ma'am? You have to follow anti-Markovnikov rule. Anti-Markovnikov rule. What is anti-Markovnikov rule? Just opposite of Markovnikov. In Markovnikov, we are adding negative part to that doubly bonded carbon atom which has less number of hydrogen atom. But over here in anti-Markovnikov rule, we are going to add, the negative part to that doubly bonded carbon atom which has more hydrogen atom. So this is what is in hydroboration oxidation. It occurs in the presence of B2H6 THF, and even instead of B2H6, this is basically diborane. They can even write BH3 twice, okay? So that is also written on the question paper sometimes in the presence of H2O2 NaOH. Hydroboration is this part and oxidation is taking peroxide with NaOH. Clear, everyone? Now similar thing you need to observe it over here. If I am observing over here your reaction of hydroboration oxidation, over here students, indirectly you are adding water, and with the indirect one you are going with anti-Markovnikov rule. Remember one thing, if I am giving you an unsymmetrical case, let's say I am giving you this case over here and I am writing on the arrow B2H6 THF and your H2O2. That means you have to do hydroboration oxidation. Indirectly you have to add water. Now if you have to indirectly add water, you have to add H positive and OH negative. Now with the help of which rule you have to do? With the help of anti-Markovnikov. So negative part will go to that doubly bonded carbon atom which has more hydrogen atom. It will come over here, it will go over here. I don't know why this magic is happening. So yeah, it is like this. So what are you'll get over here? You'll get CH3, CH2, CH2OH as the major product. Now see, in this case Markovnikov rule was followed. In this case anti-Markovnikov rule was obeyed. Clear everyone? Now students, proceeding to the previous one, this reaction we have done, this reaction we have done. Now comes this alkene reaction. In this reaction again we are taking an alkene and we are reacting this. This is basically oxymercuration, demercuration reaction. So this is basically again an indirect addition of water. You are going to obtain what? You are going to obtain your alcohol. See, in all of these cases you are obtaining what? Your alcohol. In all of these cases you are obtaining what, ma'am? Your alcohol. Yes everyone. So coming to the next reaction that we have with us, the next reaction, the furthermore reaction is with PD and H2, with you are taking NaBH4. Okay, now what is the reactant you are taking? You can prepare it from ketone as well. You can prepare it from ketone as well. Even you can prepare it from acid chloride or acid halide. This is acid halide or acid chloride. Now what you are taking is, you are taking LiAlH4 with NaBH4 and you are going to do this, you will get alcohol. Now if you are taking, aldehyde, from aldehyde also you can prepare your alcohol with the presence of what? LiAlH4. This is again a reduction process that occurs over here. And if you are taking aldehyde, you are reacting it with RMgX, that is Grignard reagent and water. You can even prepare your alcohol. You can even prepare your what? Your alcohol. Clear with this part everyone? It was a very simple reaction. It was a very basic reaction if I would talk about. Now students, do you remember one of the methods of preparation we did in the very first chapter, haloalkanes, haloarenes? What was that, ma'am? If you are taking your, sorry, for example, if you are taking RX and if you are reacting, let me do it on the slide only. Yeah, see, for example, if you are taking RX and if you are reacting it with NaOH, okay, this is positive, this is negative, this is positive, negative. So this is going to, substitute it. This is basically an aqueous NaOH. What are you going to get? You will get ROH and NaX liberated out. This is basically nucleophilic substitution reaction. This is basically nucleophilic substitution reaction in which OH negative is coming and it is displacing what? It is substituting what? Another halogen atom and taking its place. So this is basically nucleophilic substitution reaction and it comes under the category of SN2 reaction, bimolecular nucleophilic substitution reaction. So this is also one of the methods of preparation that you have already done over there. Yes everyone, that's clear. I hope so everybody has written the method of preparation flowchart over here. Now students, we shall proceed towards what? We shall proceed towards the physical properties. Let's everyone now talk about the physical properties. If I'll talk about what are the physical properties, it's very easy. See now, what are they saying? They are saying that alcohol and phenol consist of two parts, an alkyl or an aryl group and an hydroxyl group. The properties of alcohol and phenol are basically due to the hydroxyl group, that we have OH group, right? In alcohol, we have that on aliphatic ring and on phenol, we have an aromatic one. The nature of alkyl and aryl group simply modify these properties. Now, what is the basic property that you need to know in physical one? The very first and important one is boiling point, everyone. Boiling point depends upon two major factors. One is molecular mass. And other one is branching. It depends upon two major factors, molecular mass and branching. If I talk about molecular mass, students, always remember that boiling point is directly proportional to what? It is directly proportional to molecular mass. Okay, more the molecular mass, more will be the boiling point. The next part is, it is inversely proportional to branching. Where there is branching, no students, the boiling point is very less. So this order is generally asked in question papers. Do remember that. Other than this, let's talk about, if I'll talk about boiling point of alcohol, students, it has the highest boiling point, but less than carboxylic acid. It has highest because why? It has highest than ether, it has highest than aldehyde ketone. Why? Because it can create hydrogen bond. It can participate in hydrogen bonding, that's why. Clear? So you should know these various basic factors about it. Now students, this is about the things that I've already told you, so let's read about it. Boiling point. Boiling point of alcohol and phenol increases with increasing number of carbon atoms. That means what? Increasing what? Increasing molecular mass, right? That means increasing the van der Waals forces. Now, in alcohol, the boiling point decreases with increase of branching in carbon chain. So I told you it is inversely proportional to branching. Yes everyone, this thing we have already done. Now comes about the solubility. Solubility of alcohol and phenol in water is due to their ability to form what? Due to their ability to form hydrogen bonds. They can form hydrogen bonds, so they are soluble. Solubility decreases with decrease in size, basically. Several of the lower molecular mass of alcohols are miscible with water in all the proportionals. Clear? This depends why? This depends upon the hydrogen bonding. Now comes the chemical reactions of alcohol if I'll talk about. So in alcohol chemical reactions if I'll talk about, it's a very basic part. See, in alcohol what do you have? You have ROH. If basically OH bond is breaking up like this, okay, so that is basically the two cases you are going to study. The very first is acidity, the second one is esterification reaction, when you are breaking the OH bond, okay. Now in alcohol only, if you are breaking which bond, you are breaking this bond, RO bond, ROH bond. That is basically these reactions. At that point of time, these reactions will occur. Lucas reagent, what is a Lucas reagent? When you are taking HCl and ZnCl2, that is your Lucas reagent. What else reaction you are going to do with PX3? Even with PX5, E part is with PX5 as well. Then is dehydration and then is oxidation. So these reaction occurs when you're going to break ROH bond, and when you're going to break the OH bond, these two things will occur, acidity and the esterification reaction. Now students, these are the chemical properties. I have lined up all the chemical properties. These are the chemical properties on a single sheet. These are the chemical properties on a single sheet. Let's understand it. So always remember students, when you are taking Lucas reagent, that is HCl with ZnCl2, this is Lucas reagent. This is Lucas reagent. It's very simple, very simple. Water will eliminate out and the Cl will get directly attached to this. You will get CH3, CH2, ClC. See, with 1 degree and 2 degree, directly you have to remove water and you have to do this in presence of Lucas reagent. But if you are taking 3 degree alcohol, students, no need to take ZnCl2. You can directly just heat it and you can get your, final product. Clear with that part? Now, if you are taking students CH3 MgBr, now this is a Grignard reagent and you are reacting it with your alcohol part. Now see here, this bond is going to break. This is O negative, H positive, this is negative, this is positive, right? So what is going to happen over here? It's very simple. The positive end will go over there. You will get CH3, CH2, O negative, Mg positive, Br. See, if you are reacting it with Na, now this is basically based upon the acidity part. That means when you are breaking which kind of a bond? The OH bond. If you are breaking the OH bond, Na positive will get attached to the O negative. It creates CH3, CH2, O negative, Na positive. This is the very first case, the acidity case. Now, if you are taking concentrated H2SO4 at 170 degrees Celsius, it will form alkene. It will form what? It will form an alkene. When you are taking, concentrated H2SO4 with 170 degrees Celsius. Remember, if you are changing temperature, you will obtain ether. So that's why you have to take 170 degrees Celsius, you will obtain an alkene. Now, if you are taking Ki, K positive, I negative. In the same way, it is what? It is very simple. It is positive, OH is negative. So this positive will get attached to the negative. You are creating alkyl halide and KOH will be liberated out. Simple. Now, next reaction is with SOCl2, which is basically what? Which is basically your thionyl chloride. If you are doing it with thionyl chloride, again what is going to happen? You are going to obtain an alkyl halide, SO2 and HCl gas will be liberated out. Next reaction is with PCl3. If you are reacting with PCl3, again alkyl halide will be obtained and here H3PO3 will be liberated. Now when you are taking PCl5, see what you have to do in the case of PCl5. If you have this, no, CH3, CH2, OH. If you are taking PCl5, it is PCl3, ClCl respectively. Break the bond. What you will get? CH3, CH2Cl, HCl and POCl3. So this is what we are obtaining over here when you are taking what? When you are taking PCl5. Clear with this part, everyone? Now when you are doing the oxidation, remember, alcohol on oxidation will give you directly carboxylic acid. But if you want to obtain aldehyde, take PCC. Take PCC. If you are taking that, if you are taking PCC, you will obtain what? See, now there are various reactions that you are doing. If you are taking PCC, you can obtain aldehyde. Otherwise, directly you are going to obtain the carboxylic acid. Now, you can take Cu also with 300 degrees Celsius. If you are taking Cu with 300 degrees Celsius, you will obtain what? Again, an aldehyde. Primary alcohol will give aldehyde, secondary will give ketone, tertiary will give alkene. See here also PCC taken aldehyde. Cu with 300 degrees Celsius given aldehyde. So primary is going to give you aldehyde, secondary will give you ketone, tertiary will give you alkene. Remember that, students. So these were all about what the chemical properties of alcohol. I guess this is so clear to each and every one of you. Please kindly write it down, students, so that now we can start with the phenol part. So now we are going to proceed with the phenol part. Now we are going to proceed with what, ma'am? With the phenol part. With the phenol part, everyone. Yes, shall I start? Everyone write it down, till then I'll drink a glass of water and then we are going to proceed with the phenol part of ours. So these are chemical properties, but first let me do the preparation of phenol. Students, if I'll talk about the preparation of phenol, see what happens. You have heard about aniline, right? So first is from aniline. Or in some books they have done from diazonium salt also. I'll tell you that as well. See, first of all, from aniline. What is aniline? Benzene ring holding NH2 group. Now, when you're going to react it with NaNO2 and with HCl, what you will obtain? You will obtain diazonium salt, that is N2 positive, Cl negative. This is what is obtained as diazonium salt. What it is, ma'am? It is diazonium. It is diazonium salt obtained over here, right? So what they can give you, either they can start reaction from here or from here. So I've already told you, initially it is prepared from aniline. Diazonium salt is prepared from aniline. Now this on reaction with warm water, what are you going to get? You will obtain what? You will obtain your phenol. This is the very first method of preparation of phenol, everyone. This is the very first method of preparation of phenol, everyone. Just write it down, students. Write it down, students. Now comes the next reaction, that is from benzene. From benzene. You can even prepare phenol from benzene. How? If you are taking benzene and you are reacting benzene with V2O5, vanadium pentaoxide, you will obtain your phenol. You will obtain your phenol. This is again a method of preparation to obtain phenol. Clear, everyone? Just write these two methods so that I can move on to the next slide now. Now we are taking salicylic acid and we are reacting it with NaOH and CaO. This is salicylic acid. Now when you are reacting it with NaOH and CaO, what are you going to obtain? Very simple, ma'am. You will obtain your phenol. So students, these are your methods of preparation in order to obtain what? Phenol. Now comes the next method, that is cumene. From cumene. From cumene, what is a cumene? It is isopropyl benzene. Okay, this is a cumene. Now what you have to do is, you have to do oxidation first of all. You are adding O2 in this. How O2 will be added? See. This thing will remain same. Just this O2 oxidation will get linked over here as a peroxide linkage. Now this is a peroxide linkage over here. Now it's very simple, students. What will happen? This complete group will get separated over here on heating. What are you going to get? You will get your phenol, as well as you will obtain what? You will obtain an acetone. So this is again a commercial method to prepare acetone also. This is again a commercial method to prepare acetone also. So this is also one of the most important methods of preparation in order to obtain phenol, that is from cumenes. That is from cumenes you can do so. Clear, everyone? Just write it down. These were methods of preparation. Now we shall be proceeding towards the chemical properties, everyone. Chemical properties, everyone. Shall we? Shall we? Okay. Here starts with the chemical properties of phenol. See students, if you are reacting it with NaOH like we did in the acidity case of alcohol, we got what? We got R, O negative, Na positive. In the same way, we'll get this benzene ring, O negative, Na positive, right? This is what is when we are treating with NaOH. Next is when you are treating it with zinc dust. When you are treating it with zinc dust, you are obtaining what? Benzene ring. You will obtain what? Benzene ring. Next, it with PCl5, you will obtain chlorobenzene, POCl3 and HCl, right? Another is with PH, basically this is phenyl ring, then C double bond to Cl, you will obtain this part. right? With NH3 and ZnCl2, you will obtain aniline. Now, there are further more reactions if you can go through, like you can go through the HNO3 reaction. You can go with HNO3 reaction and H2SO4. What are you going to obtain? Here will be NO2 group attached at the ortho position, as well as at what? As well as at the para position. So this is when you are taking HNO3. This is what when you are taking HNO3. Now this kind of a reaction we have already done. Clear? This is when you are taking dilute case. If you are taking concentrated, no students, you will obtain NO2 on both ortho and para. On both ortho and para. Clear everyone? On both ortho and para you are going to obtain. Just everyone write down this reaction. This is the case of NO2. This is the case of which, ma'am? This is the case of NO2. Done? Now, if you are taking Br2 with CCl4, you will obtain again what? Ortho and para product. But if you are taking Br2 with water, you will obtain both the products, both together, ortho and para, both together. That is with water. That is with water. That is with water. With CCl4 it is different, but with water that is. Now let's take the next one. If you are taking CH3Cl, you will obtain CH3 at the ortho as well as at the para. If you are taking CH3C double bond OCl, what you will obtain? OH will remain as it is. Here it will be C double bond OCH3. This is at ortho. And what is the para product? C double bond OCH3. This is the para product. So these all are basically the chemical properties of whom? The chemical properties of phenol. Clear with this part everyone? It was easy, it was very simple. Everyone just take a minute, write them down so that now we can start with the last part of ours, that is ether. Everyone just take a minute, write them down so that now we can start with the last part, that is ether. Okay, so this is basically the methods of preparation of ether. What exactly is ether? It is ROR. How you can obtain is, the very first reaction that you can do is, you can take, your alkyl halide, that is RX. You can react it with CH3CH2ONA, and what you can observe is, it is positive, it is negative. It is basically, now see, this is negative, this is positive. So Na positive, Cl negative will liberate out as NaCl, and you will get attached to this one, so it will get CH3CH2O CH2CH3. So this is again a method of preparation of ether. Now, if you are taking alcohol and you are reacting it with H2SO4 and at 140 degrees Celsius, again you are going to get what? Again you are going to get ether. Clear? Clear? Now the next part is, if you are taking again alkyl halide and you are reacting with dry Ag2O, you are going to obtain ether. And the last one is, if you are taking this part over here, you will obtain with a Grignard reagent, you can obtain your ether. Clear? Okay. Now students, comes the chemical reactions of ether. If I'll talk about, see, ether basically is ROR. If you are reacting it with PCl5, what exactly you are going to obtain? See, you can write it as ROR and then PCl5 as PCl3, Cl and Cl. See what you are obtaining. You are obtaining 2RCl and you are obtaining POCl3. So this is the first product obtained over here with the PCl5. Now if you are reacting ROR with HX, what you will obtain? See, it is negative, it is positive, it is positive, it is negative. Connect positive with negative, you will get what? RX. What else you will get? You will get basically, this will get to this, you will get ROH. Alcohol is created, right? Now, what else can be the chemical properties? If you are reacting ROR with PCl3, what are you going to get? Again, you will get RCl over here. Very simple part. You will obtain alkyl halide over here. The next reaction that you can go with is, if you are reacting RR with basically what? Let's take an example of SOCl2. So here also students, what you will be obtaining? You will be obtaining RCl. Simple students. So these are the chemical properties of whom? The chemical properties of basically are ether. Clear everyone? So this students, now we are going to end our today's class over here. I hope so. You have covered alcohol, phenol and ether completely over here. Now there are some of the things that you should read from NCERT, such as, you know, about some of the properties of methanol and all of the alcohols. Okay, so that is to be done from NCERT. That is the theoretical part that you have to read from NCERT. Rest, I have covered the methods of preparation, the chemical properties, the physical properties with the help of flowcharts, and even we have done the nomenclature and the classification. I hope so today's segment was helpful for you. You have completely revised, completely done the ultimate recap session of this particular chapter, alcohol, phenol and ether. Now students, in the next class we shall be proceeding towards the next chapter of yours, that is aldehyde, ketones and carboxylic acid. Also one more thing students, there are some of the, you know, detection methods, detection test, distinction test, and distinguish between some of the you know, reagents. So that we are going to do basically in the last chapter of organic chemistry, that is the distinction test, that is about some of the important reagents topic. Okay, and till then students, keep smiling, keep learning. Now I shall meet you in the next lecture of aldehyde, ketones and carboxylic acid. Thank you so much. Have a good day. Take care of yourself.